Okay, looking at day 3 here, AB4, we have a question on continuity, which some people have, questions on very often. Okay, continuity means it's continuous, so there can be a corner in the graph. That would be the differentiable piece. It wouldn't be differentiable if there's a corner in the graph, but continuity means you can draw it without picking up your pencil. So the left-hand side and the right-hand side, they should meet up. If they don't meet up, then it's not going to be continuous. There also shouldn't be a hole in the graph. So you have to check that even if the limits equal each other from both sides, that the value is also equal to that. So I have here the list of things to make something continuous. There we go. So these are the things for continuity that need to happen. Now I use P instead of F because we're talking about P of X here. So we're going to start with those, and then we're going to try to prove whether this is continuous or not at 3. So the first thing is to find if P of 3 is defined. So that's what I'm going to do first. To find P of 3, we're just plugging 3 in the equation. And if we're plugging 3 in the equation, we would be using this one when x is equal to 3. So we're going to use the 4 f prime, and if we plug 3 in for the x, we would get 0. And to find f prime of 0, we're using the graph of f, and f prime would be the slope. So the slope at 0 here. This is a line. You can use that entire line. We rise 2, we run 4. So 2 over 4 would be a half. So we've got 4 times a half, which is 2. So P of 3 is defined. Check, got that one done. Then we want the limit to exist. And for a limit to exist, that would mean that the left and the right-hand sides have to equal each other. And this gets a little bit tricky here. As we approach 3 from the left, we're using the top one here, f of x and g prime of x. And then we have to take the limit as we approach 3 from the right. And 3 from the right would be using that 4 f prime of x minus 3. Okay, so for this one here, we have to remember we're approaching 3 from the left-hand side. Okay, we're not actually plugging in 3. And we often say like, oh, just do a direct substitution, plug 3 in. This is a one-sided limit, so we're approaching 3 from the left. When I find f of 3, if I just go to this graph and I look at f of 3, it's like f of 3 doesn't exist. But what is the value of f of 3 as I approach 3 from the left? So I'm getting really, really, really close to 3, but I'm not actually getting to 3. So as I approach 3 from the left-hand side here, the value is getting infinitely closer to -1. So this would be -1. And then g prime at 3 is -2, so we end up with 2. So it's looking good so far because all this stuff is matching. And this one here, same idea. We plug in 3, we get f prime of 0, which we already did up here. We get 2. So then we know that the limit exists. Because the left and right hand limits are equivalent. And then the third thing here is that the limit as we approach 3 is equal to the value at 3. So you might want to write these things out. This is for continuous. And so then, is it continuous? Yes. P of x is continuous at x equals 3. There we go.